Hello everyone, this is a video lecture for Calculus 2, section 11.2, series, or infinite series I guess. Let me just give you a quick example of what we're going to be talking about, and then we'll actually do some homework problems. Say I've got the summation of n equals 1 to 4 of 2n plus 1. And so what we do here is I plug in the 1, 2, 3, finally the 4, I add them all up, and then I'm done. So I plug in the 1, I plug in the 2, I plug in the 3, I plug in the 4 is the last number we need, so I take all these, I'm going to add them all up and get a number. That's 3, 5, 7, 9, add them up, you make 24. That's the idea. Now, I know my symbol's kind of weird. Technically, it probably looks more like that, but I just boop, real quick like, and that's the summation symbol. Summation. In Greek, it's a capital sigma, so it makes a s sound. It's kind of like a big S. And in Calculus 1, if you remember, integrals, which are big S's, are related to infinite summations. Wow, look at that. So, moving on. Let's actually do some homework problems. I got 11, 2, 0, 0, 3. So I got summation of n equals 1 to infinity of a sub n is equal to 1. And what they say, they want this, they say given that our partial sums, I guess you would have a subscript, n or s sub n is equal to 8 minus 4 times 0.9 to the n power. All right, what is going on? Like, this is not this very first question here. It's not anything close. It's totally different. They're trying to tie in the previous section with the sequences in right here with this partial sum stuff. I'm not really a big fan of it myself, but we could just go through and get it done. When they're saying partial sums, what they're trying to say is that this infinite summation of a n is equal to the limit as n goes to infinity of Sn. Okay, so in a way these are equal. This is equal to that. Well, it's funny because they already gave us this, so all we're really needing to do as per the formula is just find the limit. And so I'm going to say limit as n goes to infinity of 8 minus 4 times 0.9 to the n. They say go ahead and find that out. If you do the math, you plug in infinity here, 0.9 to the infinity actually goes to 0, so all that stuff cancels out. 8 minus 0 is 8. And there you go. That's all it was. It was very simple. You're just doing the limit there. But they try to make it confusing, so that's why I talk about it. 11, 2, 0, 1, 2. So it says find 10 partial sums for n equals 1 to infinity of cosine of 6n. And then they're going to ask if it converges and diverges and stuff like that. All they're really wanting is to plug in n equals 1, and so then it's 6 times 1 cosine 6 in radian mode. I'm going to remind you, this is radian mode. Do I have that on my notes? Yep. Is 0.960178. Awesome. N equals 2 is going to be this previous result, so cosine of 6, and then I'm going to add cosine of 12. So previous plus the next one, you add them up. Now I get a 1.80402. And these are your answers. They say to do it 10 times. And then at the very end they say, hey, is it converging or diverging? The answer is diverges. Now, what's going on, the reason why it's diverging is not because it's going up, 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 up. It's not like that. Remember that cosine does this, right? And so we're just alternating between 1 and negative 1. And yes, we're adding those up, and so I'm saying take that one plus this 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 one. Well, eventually you're going to add a lot of negatives with a lot of positives, and you'll get around 0, but the thing is, it's never just staying at 0. It's always going to be changing. So it's never converging, thus diverging. We had already talked about this in the previous section, and regardless of it being a summation or not, this cosine is never actually approaching a single number. Give me one number that it's actually going to be getting closer to, and it's not. It's always alternating. It's always changing. So it's not converging, therefore diverges. Okay? But that was again from the previous section. 11.2.0.1.5. I have a sub n is equal to 6n divided by 4n plus 1. And they ask two different questions. They say, looking at this sequence, is it converging or is it diverging? It's multiple choice. Converging or diverging, just the sequence here. So like if I plug in a 1, a 2, a 3, a 4, a 10, or whatever, up to 100, what if I plug in 1,000? What would I be getting, you know? What's going to happen is that these are actually the same power, and so because they're the same power, eventually you're looking at a horizontal asymptote as the front fraction, 6/4. Is that a single number? Yes, so it converges. They'll say converges to what? You're going to say 3/2, 6/4, whatever. I mean, I guess in a way, and this is bad math, I'm just going to remind you this is bad math here. We got 6 times infinity, we got 4 times infinity plus 1. Well, anything infinity plus 1, that's not going to matter. These infinities cancel, and this is bad math. Don't think that you're supposed to be doing this every time. I'm just doing a visual representation of what's going on. Okay, that's all. Okay, cool. So the sequence is converging. But now they're going to ask, what about the summation of that same equation-y thing, that same formula? What about the summation as I go to infinity? I guess n equals 1, there you go. And so the series, the summation, is what? Converging or diverging? And I'm going to tell you this one here is diverging. And so the reasoning behind it, and so like basically what's your answer? You might have to type diverges. I can't remember what they have on WebAssign. But imagine that you have this here and you're plugging in a 1, a 2, a 3, a 4, whatever, and you're getting some numbers. Well, eventually, plus, you're adding them all up, right? Summation series. Eventually, it's supposed to limit itself to 3/2. And so as you go towards infinity, you'll just be adding 3/2 again and again and again. And notice here, if you keep on doing that forever, you're adding 3/2. So plus 1.5, let's just say plus 1, plus 1, plus 1, plus 1, plus 1. I mean, right here, if that goes on to infinity, what you have on your hands is infinity, which diverges, okay? If you were adding 0, it wouldn't change, but adding a number every time, like I'm going to just forever add $1 every single minute to your wallet. So every minute, I'm going to come by and give you $1. And if you stand there long enough, I know that's kind of maybe a little too long, but if you stand there long enough, you'll be super rich. You have to stand there a long time there, of course, but it would work. All right, 11.2.0.2.3. I have this sequence 5, or it's a series technically, 5 minus 8 plus 64/5 minus 512/25, and then plus ... and it keeps going on forever. And they say find the infinite summation of this. Basically, add all the stuff up as it goes towards infinity and tell me what you get. And so we have to kind of understand what they're asking for here, what's going on. Like give me some kind of formula, I guess you can say. So 5 goes to 8, and then all of a sudden to 64/5 and continues on. I think that these two in the beginning are deceiving. But if you go from here to here and here to here, you can start to see a pattern. Notice that 5 times 5 is going to make it 25. So in the bottom, it looks like I'm multiplying by a 5. in the top, I'm going 64 to the 512, and I'm multiplying that 64 by 8. And so let's back up now. What if I took this and multiplied it by 8? Wouldn't I get 8 times 8 is 64? Yes. But so how did I get a divide by 5 here? Well, it was a 1 right there, so 1 times 5 is 5, right? And then this 5 here is kind of weird because it's 5 over 1. But, I mean, you could also rewrite this as 25 over 5, I guess. There's a way here with this 5. I think it's with I have to divide by 8 or something like that. Anyways, this is what's going on. We got the 8/5 going on, and you only need the 2 in order to recognize a pattern. So 8 on the top, 5 on the bottom, and so what's going on is I'm multiplying it by this 8/5 business. Each term gets multiplied by 8/5 times the previous one. I did it a little different on my notes here. I did the 8/5, but I kind of did it at the end. In a way, I'm saying this is my my R for my geometric series. And geometric series has a formula. It's, well, I guess it's basically just a sub 1 r to the n minus 1. And so what we're doing is we're taking this n that goes to infinity, and if I put this 8/5 in there, 8/5 to the infinity, notice that this is bigger than 1, and so you're going to basically get infinity out of this. It's going to be a diverges. And that's your answer, is diverges for this one. But let me do a little bit more crude way, because we'll be getting to this geometric stuff a lot, and I'll show you on the next problem more specifically this formula. This is all from college algebra. I mean, we've seen it before. It's just been a while, and I'll remind you more on just the next problem. Here's how I did this problem more crudely. I'm saying I go from 5 to 8, and I know it was a positive 5 to a negative 8, but like, what's the difference between these guys is like a number. Let's go with just negative 3, of course. And then I'm going to go from negative 8, and I'm going to add the 64 over 5. What I'm going to result from here is a positive 12.8 if you go and do that math on the calculator. And so if you follow this here, and I didn't do it all, I got 3, a 12, I'm just going to make stuff up here. What about a negative 24, and like a positive 48? I'm just making stuff up, who knows? And what I'm getting at is that these are going to get bigger and bigger and bigger. Eventually you'll have negative infinity, positive infinity, negative infinity, positive infinity. Not that they cancel, but that you're going like dun, 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 dun. And so are you converging? No. You're like wildly diverging. It just sometimes it's super negative and sometimes it's super positive. And so that's, I guess, another proof-ish to how this diverges. Okay. Again, that's more crude, but it at least gives a more physical sense of what's going on. All right, so I've got summation of n equals 1 to infinity of 5 times 0.9 to the n minus 1. Now I'm going to say, and this, they just say find it. Well, this is that geometric series stuff again, and we'll be very familiar with this as we go through chapter 11. A sub 1, that's an R, stands for ratio, and then your n minus 1 term, or just n is fine. And so if you see this format, it's an infinite geometric series, and there's a special formula just to like get the answer. Like, here's your answer. S, just capital S, I guess infinity, I put a little sub-infinity sometimes, is a sub 1 divided by 1 minus r. Again, you've seen this back in college algebra, I know, because, well, I teach that class, I know about it. So technically you've seen it, but I'm just reminding you, if you see this format with the infinity and stuff, it's literally just this formula here. You plug in the numbers and you get an answer. And so I have a 5, I have a 1 minus 0.9. And so 5 divided by 0.1, it's technically times a 10, so you're going to get 50 as your final answer. And so that's a converges. Notice that my answer is not infinity. And this formula wouldn't work anyways if it was going to diverge. So we're looking down here, like right here at your R, to make sure that your R is between negative 1 and 1. Now, I think that -1 still converges. I'm not 100% sure, but +1 doesn't. I can't remember specifically. That is definitely going to be a question for later as we go through the rest of this, this chapter. But for now, you're looking for numbers that are between -1 to 1. Those are going to converge to a single number, and just like you have it right there. If you have something outside of that, say like on the last problem, notice that my 8/5 is more than 1, and so it's going to diverge. Just automatically, you don't even have to worry about it, just diverge, done, next question. Okay, and here we go to the next question. So I've got 11, 2, 0, 1, 0. I got my infinite summation. You can notice I'm not putting n down here very often, just shorthand. 6 to the n, and then -5 to the n, and then -1. And they say, hey, does this converge, diverge? What's going on here? I'm going to do this thing. I'm going to be jumping far ahead. Comparison test. And we'll be talking about all these different tests here. I think it's the next section. But I'm just going to say that this is kind of sort of like saying -6/5 to the n. Notice that this -1 here in the bottom is so tiny. It's so small in comparison to everything else that I'm just going to eliminate him. And I'm just saying it's kind of equal to, it's not exactly the same, but it's kind of equal to this guy right here. Well, notice that this is, again, geometric. There's a 1 in the front, and then I have my r, and then I have my n, or n-1 up in the top. So I say, oh, well, evaluate my r. Well, my r, is it between -1 and 1 to converge? Is it a fraction that's inside -1 to 1? No, it's not. In this case, r, I guess you could say absolute value of r, is greater than 1, greater than or equal to 1. And so it's going to diverge just by looking at that. Again, not like the last problem, but like this problem here. This was bigger than 1, therefore diverges. This guy was smaller than 1, therefore it converges. And that's all it comes down to. So this guy right here is bigger than 1, minus, plus, doesn't really matter to me. Diverge, and done. That's your answer. You literally type diverges. that's you're done. 11, 2, 0, 4, 7. And so I've got infinite summation of the arc tangent of 3n. They say, go ahead and find out what that is. And I'm going to give you the answer immediately. This diverges. And why? Why? Well, arc tangent, if you graph it, it actually limits itself right here at pi over 2. And so that, and down here at negative pi over 2 as well. And that's pretty cool. So, I mean, it's never going to get higher than pi over 2. So, obviously, this is converging to a single number. Yeah, that's true. Arc tangent is converging. That is true. But they're asking for the summation of arc tangent as you go to infinity. So, I'm saying as I keep going out this way, I'm going to take this height, at pi over 2, and I'm going to add it, plus a pi over 2 here, plus another pi over 2 right here, plus, here's another height. Oh yeah, it's pi over 2. Plus, plus, plus. So I'm basically saying pi over 2, plus 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 pi over 2, all the way out towards infinity. Pi over 2 is about 1.57, and so you're adding a whole lot of 1.5s, or just, let's just say 1. 1 plus 1 plus 1 plus 1 plus 1 out to infinity. You're going to get infinity. You're going to get infinity, and therefore diverges. So yes, the sequence converges, but the series diverges, okay? And see how there's a distinction there. And again, there's like a ton of these examples, and I'm trying to show you different ones. I suspect that you're probably not going to get all of this at first. But as you keep cruising through the rest of the sections, I hope that it starts clicking more, okay? This very first section is kind of like an introduction into what we're going to be doing for the rest of the chapter, and that's fine. And I just kind of wing it sometimes, like this one. I'm just winging it, and that's okay. Right now, we're just talking about it physically. We'll have actual tests and all kind of little stuff later, okay? Anyways, the next one here, it says, hey, figure this guy out right here. And first off, does it converge or does it diverge? Let's just ask that question. And if it diverges, let's just say it diverges, your answer is infinity, or you type diverges, and you're done, so you walk away. On the homework, you get multiple attempts. So guess what? You click diverges. If it works, you're done. If it doesn't work, try to do converging. See how we're laughing? We're laughing about that, right? Oh, but on your quiz, you can't do that. You can't, because you don't, well, actually on your quiz, you might be able to do 1 or 2 times. But I wouldn't suggest doing that, especially on an exam. Just clicking diverges, and then hopefully you get it right. No. We have to do the math. So what do we do here in this case? I'm going to say converges. So why? And so now I'm going to actually show you why. Again, there's a lot of little formulas that I'm going to be using right now, like the geometric stuffs and everything like that, that we'll be seeing later in this chapter. This one is called P-series. This one's called P-series. And so if you see a summation that looks kind of like this here, this is n to the p power. If you see it like this, and your p is greater than 1, then it's going to converge. Otherwise, it's going to diverge and all that stuff, okay? And so looking at this guy, the 4 doesn't really matter to me much. This -1 doesn't really change much. You can't just get rid of a 4. You got to put a 1 up there or something. And I'm really looking right here at the power, and notice that 2 is greater than 1, and therefore I'm going to just say converges, done. I mean, and that's it. That's the end of that story there. It's more of a recognition of what we're supposed to be doing. Okay, so I got converges. Awesome. Well, now, because it converges, to what? Like, you're telling me, when you say converges, you're telling me that this guy is going to go to a single number. I can actually say this dude, this original guy right here, is equal to like 5, or I don't know, maybe 100, or something like that. It's actually equal to a single number. What is that number? And now we have to do it on our own. And this is where it gets a little bit sad because it takes a long time. But we're going to do this together, and it'll be fine. This is my inside, and what I'm going to do is factor the bottom. My 4s don't look very good today. Any day, honestly. And I'm going to do partial fractions. Now, I'm going to skip a lot of these like blah blah steps because we've done all this before. I just want to make sure that you're understanding where I'm going with this. So I split them up. I got an A and a B. And so then I say 0n plus 4, again at the top, is equal to a n plus 1, a times its opposites, b times its opposites. I messed up. Sorry, opposites would be this guy here. Okay. And you go and do the math. A is equal to negative b, blah, blah, blah. A is equal to negative 2, b is equal to a positive 2. Again, it's not hard. I only skipped like one step there. And so then I can go back and say my original here is equal to, and now I can split this up into saying a negative 2 with the n plus 1, and then a positive 2 with the n minus 1. Okay. So now I need to find the infinite series of this guy. And if you were just to do this on your own, I mean, perhaps. I mean, I don't know how we would all get to the same conclusion here. It's just, this problem, it kind of just throws a left field out at you and then says, well, didn't you know that? And no, I didn't actually. So I'm trying to do this weird problem with you, and you're thinking, well, okay, we did all this, great, awesome, I understand, we're at the same place. Why? Why did I do this? How is that any better, you know? So what we're actually wanting to do in this particular case is recognize that this is telescoping or telescoping. Telescoping? I'm going to say scoping, telescoping. A telescope, I'm talking like older telescopes here, like the pirates have, and they're looking out. And so you're looking through right here, and then you got like more vision, and it's closer up, easier to see. But the thing about these telescopes is that they collapse on one another, and so you're going to, basically you can compress it down, and it ends up looking like this, and that's it. And then you can put it in your pocket or something like that, right? So you're compressing it on both sides, and then it's now smaller. So the idea here with this one is that we should be able to compress it, I guess you can say, down to a single number. That's going to be the goal. To demonstrate this, what I'm going to do is I'm going to actually start plugging in numbers. I'm going to plug in n equals 1, n equals 2, n equals 3, da 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 da, and I want to show you physically what this is going to end up looking like, okay? So I'm going to plug in a 1 to both of them. And I'm going to keep the parentheses for now. I don't want that to be a hindrance later. I'm just saying I plugged in a 1, cool. All right, next one. So now I'm going to plug in a 2. Awesome. And then I plug in a 3. And then I plug in a 4. And you're wondering how far I'm going to go. I actually went quite a far distance out. Okay. So we got this. I'm going to keep going. What I want to do is actually simplify these denominators because it's all like, this is wonky looking, I guess you can say. Oh, I did one small mistake. Hold on. Let me go back to my notes in here and see. Yeah. Did I write that down up here? Let's go back, right here. Very small mistake. You see that? I often discard it. I mean, look, I discard it on almost every other problem. But I actually wrote it this time, and then I discarded it, but I do need it. This is important here. They actually don't want you to start at 1. They want you to start at 4. So, like, actually all of these are no good. You're just going to start at 4, but you're going to do the same process. So start at 4. 5, 6, blah, blah, blah. I guess these right here were not going to be helpful. I don't really know, but it's just not part of the problem. You might have a 1 on your problem. I don't know, but I had a 4. So I'm going to start at 4 and move on. But the same idea, what I want to do is simplify the denominators. And so you can see this is going to be a 5 and a 3. And so I've got now a 5 and a 3. And then if I keep adding 1 to it, I should then get a 6 and a 4. And then I'm going to get a 7 and a 5. And then I'm going to get an 8 and a 6. And I know that we can simplify all this stuff, but that is definitely not the point in this particular case. Now I'll show you what I mean one more time, just so that we have enough numbers to kind of play around here. Okay, that's good enough for now. That's good. Okay, I just want to show you the physical what's going on here. And so I'm looking around, and I feel like there's some kind of commonalities. Notice that we have a negative 2/5, and over here we have a positive 2/5. Get rid of all these parentheses for a minute and just see them as just all numbers. Just they're all different numbers. And so wouldn't those guys cancel? Here. I see this negative 2/6 and a positive 2/6. So those are going to cancel. I see a negative 2/7. I see a positive 2/7, and those are going to cancel. I see a negative 2/8 and a positive 2/8, and those are going to cancel. And if you keep on going down the list, negative 2/9, guess what's going to be over here? A positive 2/9, right, for this next one. And so those are going to cancel. And everything here is going to cancel. Whoa, hold on. I'll show you that in a different color. Cancel, 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 all this other stuff, right? And I'm just wondering, I'm going to ask you, what do we have left over? What's left over out of all this canceling? What do we have left? Well, this guy never got canceled, and this guy didn't get canceled. And so I could take those two numbers. Notice that we have a positive and a positive. And I add them together. And I got 7, 6. And that's your answer. We finally got to the answer. We're done, complete, walk away, nothing else to do here, next problem. But I do want to talk one particular thing here. You see how these here are going to cancel as well? This is going to cancel with something over here. This is going to cancel with something over there. And they all do eventually cancel. But there's something else going on, is that these numbers here, let's just go way, way out. What if I had like negative 2 over 100, 2 over 98? Is it 98? Yeah, because there's always 2 difference. What if I keep going and going and going? What if I got 2 over like a million? And then I've got 2 over 9999998, something kind of like that. Just tell me right quick, these 2 guys right here, round to the nearest 3 decimals. What do you think you got? Well, 0 and 0. So it's also important to note that, yes, you're going to be canceling all this stuff, but like towards the end, you're just getting zeros. You're just plus 0, plus 0, plus 0, plus 0, plus 0, plus 0, and it doesn't really change anything. So you don't even have to cancel at that point. It's already done. You're done. There's nothing else to add to it, okay? So note that little bit of small change there as we go into the next problem. But ultimately, cancel everything. What didn't get canceled is your answer. Now that was all one big problem. And hopefully we don't have to do such a big problem again, because that was huge in comparison to the other ones. I mean, it wasn't a bad problem. It was still just so long. This one here was confusing to me, and I'm going to make a mistake ahead of time so that we can all learn from that mistake. Sometimes I make mistakes just accidentally, but this time I actually have it in my notes. There's a huge mistake here, and I make a point about it. So let's do that, okay? It's a good thing here. Now they say this is telescoping again. They say it, and so if they're saying it, maybe we should listen. I'm going, and it's starting at 1 again. I can actually start plugging in 4 over the 1, and then 4 over the 1 plus 1, it's going to be a 2. And then I got 4 over 2, then I got 4 over 3. Then I got 4 over 3, then I got 4 over 4. And it'll keep going forever. Not too concerned. It's telescoping, so things should cancel, right? So what I have here is I got a negative and a positive version. They cancel. Here I got a negative and a positive version. They cancel. And cancel, cancel, cancel. Again, I'm going to just real quick use a different color. There we go. Cancel, 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 cancel all the way out. Well, what was left behind is e to the 4th power. That was my answer, and they said, you're wrong. And they gave me this answer. That's their answer. Okay, awesome. Thanks. So that's exactly what I thought it would be. Well, obviously, we got most of it right, but there's something lacking. I didn't do the full problem. Why is it this -1 attached to it? Well, notice my blues canceled. Blue, 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 and then I started using green because I didn't actually write what this guy would be here. I mean, he would be a 4 over 4, but then he'd also have a 4 over 5. So yeah, these guys are going to cancel, but then I got this guy. And it'll keep going that way forever and ever and ever. Notice like last time I was saying, hey, as you keep going, you don't need to cancel anymore because you're just adding 0. Well, on this particular one, what I'm ending up with is e to the 4 divided by infinity. I mean, basically that number right there is going to keep getting bigger and bigger and bigger to infinity. Well, like anything over infinity is a 0, and anything to the 0 is a 1. And that is where they got that. Now, I did a more, on my notes, I did an actual more mathy version of it using partial sums and blah, blah, blah. But this is really what is going on here. You cancel, but you never can cancel even the last part. Last time we were lucky, and these last parts that wouldn't cancel, let's say, they ended up being 0. So I just said, hey, 7, 6 plus 0, and still 7, 6. But here, I know I canceled these guys, but like this last term, it's always one more term, right? It's always one more term that doesn't cancel, that last one. Well, that just so happened to end up, if you go to infinity, it ended up being just a 1. Okay, and again, I messed that one up when I was going through this. So are these easy to recognize? Do we just know what the answer is every time? No, I get things wrong, and then I look at it and like, here, I got this answer, and I plug it in, and they say, no, it's -1. Okay, well, why? And then I go and investigate, and I look at it, and, I ask my professor, that's me, by the way, and et cetera, and I go and find out why it's like that. Oh, it's because I technically didn't cancel that last one. Okay, I have one last problem, and it's an application problem. We got 200 milligrams of some kind of a drug is taken every 8 hours. And it says that 80% is eliminated from the body in 8 hours. Okay, so what's going on here, and I'm going to definitely graph this one for you. We take 200 milligrams of ibuprofen, let's say, or something like that, or aspirin. And so you take it, you have it in your bloodstream, and then it goes down, down, down. Over time, it dissipates its half-life and all that. Well, at some point at 8 hours, you take another dose, and it just so happens also that it's not at 0 right here. You have 20% left over, right? 80% is eliminated, so you got 20% left over. And so it's a little higher than it was last time. See right there? It's a little higher. And then, again, it starts to decay. And then at hour 16, again, are we down to 20%? No. Now we're at like 40% or something like that. Maybe it's 30. But you're at a different height, and then you take it again, right? And then it goes down and down. Well, what's going to happen is that it doesn't actually do 40, 60, 80, and then all of a sudden you're like way overdosing all the time. It's a percentage. It's not simply an addition. And so that's why I think this is not 40, but it's maybe like a 30% right there. And then it might go to like 40%, and then it might go to 45%, and then it might go to 50%. And eventually it kind of levels off. And so if you keep taking it, it actually eventually will just kind of level off at some kind of zone, okay? It won't go up forever. And so what would that be? If I sustain this every 8 hours, I take 200 milligrams, what would I have eventually, okay? So the question actually starts with saying, how much do you have after the first hour? And so first 8 hours. First 8 hours. Well, you have 20% left over. So you had 200, and it decayed 80%, leaving only 20% behind. 20% of this guy is 40, right? So I had 40 milligrams left in the body. But at hour 8, I took another 200 dose. So then I'm going to add the 200 to it, and I get 240. That's what they want for part A. And then at 16 hours, I'm going to take that 240, and I'm going to say, well, 20% is left over. I think I did my math a little differently, but this is definitely okay. 20% is left over, and you're going to add the 200 here, and I got 248. And so that's part B, and so on and so forth. You keep doing it as many times as you need. You would just take that previous answer, make sure it's 20% of that, and then blah, 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 blah. I did a more series sequentially kind of style, but then that's all part A technically on whatever. But then they ask for a formula. This is the true part B. Q sub n plus 1 is equal to what? And they're saying this is a recursive formula, which is easy because we were just doing that a second ago. It's going to be 0.2 times Q sub n plus the 200. And that's what I was doing. See, whatever I had previously times the 0.2 plus 200, and that would always give me my result. This is actually what you type in the box, okay? Now, it's kind of weird because this little n here, that's a subscript. So either you're going to go into the little box that pops up on the side and has all the stuff there and find a subscript, or you can hit Shift minus sign on your keyboard. It's that little underscore stuff. And so if you do that, it'll drop it down. You type an N, you go arrow back to the side, and it'll pop up again, blah, blah, blah. So either way, there's a lot of different ways to do it. And then part C, that was my official part B. Part C is now, what is the quantity as we go to infinity? So we go to infinity, what are we expecting to get, like I was saying? So my formula is 200 is where I start, and I am left with 20% each time. This is, again, a geometric formula, infinite geometric series. Therefore, my answer, S sub infinity, or whatever you want to call it, like this equals A sub 1 is the 200 divided by 1 minus R. You're just literally plugging in your two numbers, and you get an answer. And when you do that, you get 250, which makes sense. If you go back up here, we were already getting around the 250 zone. So 240, 248, 249, 250, 250, 250, 250, 250. Every 8 hours you take this, your body eliminates 80% of it. You'll be left with 250 constantly-ish in the bloodstream, okay? Actually, that's all I got. So we're done. Thank you very much, and have a great day.